Thank you, Lance. Really excited to be here.
Thank you, Mayank, for joining us to kick off our connections on knowledge graphs. I just finished my presentation and I'm super jazzed, as are the audience, I'm sure, to hear what you and LPL have done with knowledge graphs. So let's get this going. Just a quick introduction. Mayank Gupta, as Lance mentioned, is currently Senior VP of Technology at LPL. And I'm very pleased that he's taken the time to join us to share LPL's journey of self-discovery using knowledge graphs. Mayank, welcome. Now, I know you've been in the NEO community for a very long time, probably about 10 years or more. So how did you originally find Neo4j?
So I ran into Neo4j at a conference in Brooklyn. And it was a conversation that Jim Weber had, I think fairly early days of Neo4j, introducing graph and graph databases. And I was wrestling with several problems at that time, and the paradigm just, it was a paradigm shift for me, that presentation. And I've been an avid participant and user of graph databases and graph technologies since.
And so can you tell us a little bit about how you started off with graphs?
Absolutely. So prior to that conference, this was at the time when I was had just recently started at UBS. Prior to that, I like to call it graph adjacent. My function, my role was really around data distribution at Morgan. And what we had built was a system that essentially inventoried all of our data sources, mapped them to a logical model, mapped them to the questions that users would ask, and we would use very graph-like constructs. We were doing depth-first searches to find paths from the questions that users had to where the answers, where the data to provide those answers might live. We just never called it graph or knowledge graph or graph database, right? Having gone to that conference at UBS, I was doing a very similar function and role. It's very common at modern financial enterprises, at least, plethora of data sources, and how do you get at them, and really focusing on building out a virtualization to make it easier for people to get at the information that they needed in the context that they needed it. So we formally built something called the Integrated Data Platform at UBS. And the heart of that, the brain of that, was essentially a Neo4j based knowledge graph, which housed all of the sources, the logical mappings, as well as pathways and schedules for when data is available. At UBS, we also experimented with and took live a roles-based access control mechanism with graph databases, a very natural fit for graphs. And both of these are use cases that are very common in the industry, and at the core of them are knowledge graphs.
Yep. Go ahead, please.
I was just going to say, yeah, and that journey essentially continued when I moved from UBS on towards LPL.
Yeah. So I just found it very interesting because this dates back to even before you joined LPL, right? Your journey with graphs, and the initial use cases that you just outlined were, the focus on role-based access control lists. I mean, this is really important from a security point of view, and interestingly, this is still one of our bread and butter use cases. This hasn't changed, right? But the scope, I think, has expanded quite a bit, and now it's the centerpiece of how companies are focusing on using this for proactively identifying cybersecurity risks and preventing threats from happening, right? So, in fact, one of our speakers later on today, Hemant Prabhakaran from Standard Chartered Bank, is going to present on this. So it's exciting that even 10 years ago, this was so important, and it continues to be important. But of course, as you said, that brings us to LPL. How and where did the LPL knowledge graph journey start?
Absolutely, yeah. I think you're absolutely right. Right, where you have complex modeling, data models and modeling, and where you have data models that are changing very rapidly, graphs are such a natural fit. They are to me like the uber data structure, right? All other data structures can be described in graphs, and that's their power, right? That is truly the heart of the value proposition in graphs. So at LPL, when I joined, we had a fairly severe problem that we were dealing with. We're a very account-centric data structure, and a part of our responsibility is to do supervision and monitoring, right? Surveillance. Hey, is there any bad activity or suspicious activity occurring in accounts, right? And we would actually get a lot of triggers, not that it was that bad activity happening, but triggers or suspicions that this was happening. And what we were finding was that we were calling the same persons or same households multiple times because they had multiple accounts with us. So the very first deployment of the graph, how we commercially brought in Neo4j to LPL, was through a graph that essentially allowed us to go load up our accounts, to derive clients from them, from those accounts, and then to drive household nodes, essentially, collecting together, householded clients. And that was pretty powerful, right? We got not only our main use case met, we discovered a lot of data quality constructs, right? Where you had heavy clustering. That's suspicious. Why do I have so many people with the same SSN? Or why do I have so many people in the same town, etc., right? It actually went above and beyond what we had intended with just being able to know our households and reduce the number of alerts. So we continued on and we said, okay, how else can we apply it? Our next really serious effort with graphs was around loading up financial concepts and our help documents using a company that Neo4j introduced us to called GraphAware. And essentially they did a lot of text analysis and searching and created a knowledge graph to improve our search results, right? So the intent was when our advisors or home office users enter in search terms, they get far better efficacy. And this actually proved itself invaluable because it started to drive down calls to us, which is a bottom line concern for us, as well as it improved advisor experience because they were getting to their information, their question faster. And then we are also deeply leveraging graphs and graph technologies to build out a graph database to build out our constructs, right? So to almost build a logical model as we do new things. A lot of our ontologies and complex, our clients tend to have a lot of complexity, right? And in the financial world, there tend to be a lot of relationships. So I will have an insurance client, I will introduce them to an advisory company or a colleague who does advisory consulting, financial consulting, and they may introduce them to a sponsor who's got these products that are a perfect fit or a really good fit for my scenario. So you see a lot of the sharing and complex relationships. So we've been using our graph database to really house and drive those organizations and relationships, and that really improves our engagement with them. It gives us knowledge about them that it's not hidden, but it just makes it so much more easily apparent by using a knowledge graph around this. And then, of course, the use case that we're thinking of now that we're going to discuss through.
So it's so interesting because you're driving home the point that relationships matter, right? And that's what graph databases allow you to surface. I mean, that's so important. And you just detailed 3 different use cases there. The first one was a data management use case of what I like to call customer 360, because you get visibility of everything in that account. We could call it account 360. And then, but then I like the way, and that's typically what we call an actioning knowledge graph here at Neo4j. But I like the way you then mentioned that it progressed slowly into what we call a decisioning knowledge graph. Something to make to use to make decisions, right? And then from then on, you went to describe other use cases like the graph-based search and chatbot. And when we talk to our customers, this is exactly what most of our customers say they do. They start off with one kind of an actioning knowledge graph, and then move it slowly towards and progress towards a decisioning knowledge graph. So it's interesting, but it's, in the last 10 years that graphs have been around, it's never a one and done kind of a thing. You start off with one use case, but then you see that you can do so many use cases, you can build so many use cases on top of a knowledge graph. And that's exactly what LPL has done. So that's fantastic. But I'm sure that was just the beginning. I recently read somewhere that LPL made it to the Forbes 500 list. Congratulations on that, of course. But tell us a little bit about that. And I'm sure that comes with its own set of challenges. What are some of these challenges, and how are you overcoming them?
Absolutely. Yeah. I mean, it's both exciting and somewhat scary at the same time, right? At least for us, the data department. So what we've been seeing over the last 5 to 6 years is, as we improve our offerings, as the country engages more and more with independent advisors in the independent advisor space, we're experiencing essentially a sustained increase in transactions and business volumes, right? As well, our business has been rapidly growing, right? So we're onboarding far more practices and advisors, which brings on a lot more accounts, which brings on a lot more assets under management. So we're seeing both an organic growth at LPL and essentially inorganic growth, right? So same store sales and new store sales essentially are rapidly driving our processing demand. We essentially need to increase throughput. We need to increase resiliency and be able to handle scale. Financial services firms know that our volumes can be very spiky, right? In a good or bad market day, we get hammered one way or the other, right? And we have to be able to accommodate that. Along with that, what we need to do is, and want to do, right, is we want to improve our value provided, the quality of our data, the efficacy of our experiences, that data and information available, that enable, right? And it's very important for us to try and do this while sort of at least maintaining, if not bending, our cost curve. So this is a pretty intense problem statement for a set of data pipelines that have been built up over the last 3 decades, right? And they've been built up in a very staccato fashion. So selfishly, we're saying, as you said, you're never one and done with graphs, and knowledge graphs especially. What we're trying to do is apply the principles of knowledge graph to really not look left or right, to sort of look inwards, to self-discovery of our data department, how it functions, and transform how it functions.
That's very interesting. So are some of your data challenges, are they because you have data in various silos, and, is that one of the issues? Because that's what we've typically heard a lot of business leaders that we talk to.
Yeah, ours is perhaps not unique, but I'm going to call it, it's not a common thing. So our data is siloed, but within a couple of monoliths, right? So what we have is we have a shared fate, a dependency on a very narrow set of infrastructure, and all of it is together. So deep shared fates, but the logical construct is all disparate, right? So typically where you would see data in silos because it's in machine A, and then that's in machine B, and that's in machine C, it's all in one place, but it's not really together. And that's a big part of what we want to improve, what we want to understand, and what we want to tease apart. We wish we had silos, albeit it would still not be the optimal case, because we would face a problem similar to what others face. But yeah, our problem is compounded in that way. So it's important for us to describe. I think of it this way, right? It's important for us to know and describe on our knowledge graph the physicals as well as the logicals, right, and the conceptuals. That's a big part of our change. So not only do we want to look deeply, but we want to look at the full stack, and that's where it's going to have efficacy for us. I think I can best describe it by setting some context, right? So I very, very high level. Lots of people do it differently, but a general, like just a high level anatomy of a data pipeline, right? Just for our discussion's sake. So essentially, you have a variety of sources of signal. That could be one or many, and they have a lot of variety, right, and veracity and volume to them. And against those, you create sort of integration points, right? So, hey, we're going to go listen to this feed. We're going to go pull these data files at a schedule, or we're going to copy these archives or these log files into our processing area. And a typical pipeline will, in most cases, land all of this data into what can be thought of as a raw zone, right? And at that point, all you've got, whether regardless of the type of data source or signal that you've brought in, is a blob of bits, right? And the only structure that you've got on top of it is that I got this blob of bits from this place through this construct at this time, right? So then in the pipeline, you basically have to cross a distance. You have to cross the distance of describing the physical structure of the blob of bits, right? And so, hey, this is a comma separated file, and this is the separator, right? This is what the columns names are, and this is how they tie to each other, etc., right? Or this is a JSON document or a series of JSON documents, or this is a stream, whatever shape your data sort of physical shapes have to be described, right? Then in the pipeline, once you've sort of structured the data, when you sort of said, hey, look, I just don't have this massive bits, I've now got some structuring, you have to cross the semantic distance, right? Okay, I've got this file, it has 15 columns in it, they're named A through whatever, column 1 through column 15. What do they mean? How do they matter to me? And so typically in a data pipeline, the pipeline owner will have a semantic construct. So they're going to map that physical to their logical construct. They may do other things to it at that time, but they have to essentially map this out to a logical model, right? And then because you have this plethora of sources, typically in a data pipeline in most organizations, you'll see sort of a mastery and processing layer that says, look, I'm going to take all this information, I'm going to rationalize it, I'm going to deduplicate it, I'm going to match it, merge it. We might do some sort of quality metrics and so on it. And we're going to prepare this as quote unquote curated data sets or ready to consume data sets into data masters or systems of records. And typically a data department at that point would sort of consider them as done, but really you haven't finished yet, because now you have to get that data prepped for different patterns of distribution and consumption that people take on. As well, you have to shape and sort of sort the data for the different consumption types of consumers and different contexts that those consumers live in. So if you think through this data pipeline, there's lots of places where knowledge is coming into play, right? There's a lot of knowing that today, in my opinion, is locked away in configuration files or code or just in people's heads that forms up this construct, right? So our hypothesis is, our effort is around this hypothesis of what if we could bring all of that knowledge out as deeply as possible into a knowledge graph. In a sense, make the knowledge graph that we construct the pipeline, right? Everything else is just implementations, and you can have multiple implementations. But could we sort of think of it differently, right? Could we, instead of having all these disparate pieces, places, whether you're thinking through the pipeline or you're thinking through the enabling layers vertically behind it, what if we brought this out and said, look, here it is all in one shot, and now logically or physically you can trace any bit, any blob of data from acquisition all the way to the point of providing value, right? And if you could do that across the board in totality, you wind up in a place where you enable an incredible efficiency and visibility, transparency for the firm. And as mad scientisty as that sounds, it's actually not all that terribly difficult, we feel, right? There's a lot of effort involved, But if we sort of go through the layers of knowledge or the types of knowledge that we're describing in this data pipeline anatomy, right? So obviously we have all these different sources of data and methods of integration and so on, right? And we're going to have contracts and we have integration objects, and there's all these configurations. If we're using Tumbleweed or Kafka or stream sets, or like there's all sorts of knowledge that's available to us from these objects and from our even our raw data stores that we can source in and construct that portion of the graph out. Like, what are my physical data sources and how do I get at them? And how do I choose to get at them? The physical data descriptions, these are like, to make data useful, they have to be done. There's various markup languages that actually describe this really, really well as a class of problems. I think they've solved it, right? So your various obviously entity relationship diagrams, right? JSON schema for more tree-like shapes, XML schema and JSON schema really for tree-like shapes, right? You essentially have a variety of tools and products that can both scan and inventory your physical data descriptions for you. And these scanners, where you have special formats, are not all that hard to write, right? Your entire physical plant, which is a very important construct to us because we want to create a more resilient plant, which means we want to federate it out more. All of that, most of that in primary organizations, primarily I think like a very large percentage of organizations, are going to be available in your ITIL configuration management databases, right? In whatever asset inventory and asset management systems that you use. This is just information that right now is in this deep silo that has such power if it's part of this knowledge graph, right? Most modern firms, most enterprises are very deeply focused on logical models and repositories, right? The privacy rules, the especially in the financial space, the Basel Committee banking standards have driven really over the last 7-8 years even, firms having this information. So they have their logical models, their lineage, and their concepts pretty well baked out. Again, available for us to scan and populate into this knowledge graph, right? So now we come to the hard part, right? Where the information, in my experience, and perhaps not everywhere, is locked in today that has to be scanned out are the processing pipelines. How do I go from that raw data to my intermediate physical structures? How do I go from my physical structures through my mastering and data preparation processes? And then from there, how do I take those systems of records or those curated data sets and shape and transform them to the various points of context, right? Or consumptions, excuse me. So, and that is where we think that this is uber important for us to get into, because the other ones are easy and they have been experimented with, they've been tried to bring together, and they engender a lot of their own goodness. But if we can get into the processing details and capture those as knowledge, all of a sudden we've essentially loosely coupled the data practitioner from the data pipeline. And whether it has to be done manually, obviously there's ETL and ELT systems configurations. There are a variety of code scanners. A lot of our work is done through rule spaces. So we have the rules themselves to scan and bring into this construct. It will be work, and it's work that's ongoing. But having done this in a small set of mode, we see such power, right? We see such efficacy, because now not only have we described what's being done, but we've actually enabled a lot of benefit to us from this. So yeah, it's our focus is very much inwards. It's very much selfish. It's very much discovering and describing what we do, what a data function does for a Forbes 500 company within a knowledge graph.
It's so interesting. Thank you very much for walking us so clearly through that entire data pipeline journey, because that's very important. I think the beauty of knowledge graphs, and correct me if I'm wrong, is that it provides this intermediate layer, and what I like to call an insight layer, where it connects everything, but you don't, as a business leader, or CIO, you're not thinking about you're not changing the data landscape or infrastructure in any way, but you're just using that to get information or get data from it, and connect everything in that knowledge layer, knowledge graph layer, which then you can consume via different use cases, right? That's the beauty of knowledge graphs, and you've just described it so well right now. So it's really interesting, and I'm sure a lot of other companies are looking at data pipelines in exactly the same way, for sure.
Absolutely, Maya, right? Like we see obviously the sort of the inwards looking benefits, right? So the benefits to the data function. And the reason we started this was to say, okay, we've got this really Gordian knot of 30 years of data pipelines. How do we start teasing stuff apart? How do we start making changes if we pull here and we don't know if that's going to be impacted or that's going to be impacted? And that was opaque to us. And I would posit that that's the case at many enterprises, right? Especially enterprises that have been there for a long time. So our primary benefit is that having this transparency, now it's essentially enabling our decision making, right? We're now able to say, hey, we're going to start with this thread or this slice or this path in the graph, and if we can modernize that, we get some benefit, but it's isolated enough to start creating that journey, and then now let's do this next or these next, and so on, right? So it's really enabling our decision making on modernization. At the same time, having that transparency. And I like the way you said it, right? Describing it doesn't necessarily mean changing anything, right? Which is a very powerful concept and construct, because that is the truth, right? If you describe it, now we can say, okay, where do we have duplication? Where do we have sources of inconsistency, right? And we can start to plan not only modernizing, but optimizing, right? And then what this does is today, what you sort of see is the static between producers of data, right, or owners of data and consumers of data. By laying bare the pipeline and by laying bare the challenges that a specific concept might have to be realized, or a specific piece of data, how it's being treated before it makes it in front of a user or a consumer, you actually create you drive towards better outcomes, right? You give alignment between the two most primary folks, right? Like the consumer, the producer of data and information, and the consumer of information. So in a way, right now, data departments are in the middle of that, right? And this allows us to get out of the way, right? This allows us to focus not in mediating between these endpoints, but enabling both of them, right? Yeah. We want to enable our producers to provide data better and with more efficacy, and we want to give them that feedback loop. At the same time, we want to show the challenges and understand the needs of our consumers and bring that back transparently, create that feedback loop between those producers and consumers, right? Beyond that, and these are use cases that we are now experimenting with, is operating, right? Like if I have a problem, and problems occur, we deal with hundreds of sources of data, and somebody had a bad day or a system went down for some reason. Understanding those impacts, understanding those problems and what's going to happen, right? We can resolve problems, react faster, and in some ways, I think we can even avoid problems, right? We can be proactive. Oh, this is looking hokey. Let's change something, right? We can actually start to take a more proactive stance to avoiding problems, right? And having this transparency, I think ultimately, yes, it's about the data because data enables, but data enables business, right? And if you have easier, better data, then you're enabling the business to have better time to market, better outcomes, and really, because they have this transparency and feedback loop, get into this continuous improvement, right? Like it's not improvement for improvement's sake. It enables the spirit, right, or not, not the letter of the law, but the spirit of continuous improvement.
So I just want to say you've added to the theme of this conference that we're doing today, which is knowledge graphs for transformation. Well, knowledge graphs for transparency, right?
That's right.
not just with AI, but even with your regular use cases that are non-AI related. But anyway, it's interesting that you've implemented graphs, knowledge graphs, and I say this at various places and successfully. I'm not sure that, I'm sure there are only a few others who've had so much experience with knowledge graphs. In this entire journey, what would you say was your aha moment? And what is the key takeaway that you can share with us about knowledge graphs?
So I think the key aha moment for me was how do you describe for the long term, right? What you know, right? And enable that in a way that you can share it. So the and I say this sort of I say this gently, right? But I truly believe that knowledge graphs are one of the premier tools, underutilized tools for people to share context, right? We do a lot of work with things like ontologies and taxonomies and so on. And yes, they make sense, but if you can actually capture those things in a knowledge graph, and because our context, our understanding changes, the knowledge graph becomes the bridge, not only between sharing context, but maintaining context. And that was my key aha moment, right? Because one of the benefits of even this knowledge graph that we're thinking about is we want to start to move the organization. If you look at a lot of the data practitioners, the analysts, the power users, the decision makers in an enterprise, right? They today have to take a very imperative view of data. I want to understand where I should be investing in the next 3 quarters. Well, let me pull where my business is and what trends are. So they're describing how they're going to get to that answer instead of being able to say, I want to understand what the trends are that should drive my decision making for the next 3 quarters, right? And the graph enables that intent-based, that more declarative style than the imperative style, right? Of engaging with information. That was my big aha moment, that it's something that let me get it out of my head in a structure but now that structure both allows me to share and maintain my context over time.
Yeah, I totally agree with you. I think what knowledge graphs allow, especially business leaders, to do is to get to that value quicker.
Right.
All there, but it's just surfacing it and then getting to that value much quicker than anything else can. And I totally agree with you. Knowledge graphs are one of the most underutilized technologies around today. But hey, it's all changing. I think it's going to be the I don't want to say the decade of knowledge graphs, but definitely the year of knowledge graphs, if not if nothing else. So let me kind of finish off with a futuristic question. What role do you think graph technology is going to play in the next few years? I'm from Neo4j. Of course, we believe that it's going to revolutionize the world, but we may be a tad bit biased, and so I'd love to hear your thoughts about that.
So I think there's a few trends emerging, right? I'm going to tease out the theme that I was making around the declarative style of engaging with data information versus imperative approaches, right? In some ways, Bill Gates and others introduced this construct of ubiquitous computing quite some time back. And you see it happening, right? There are people, kids. My daughter was a 5th or 6th grader when she had the power of what would have been a massive computer back in those days in her pocket, right, with access to all of the world's information through voice, essentially. I think that for business enterprises, the power that consumers have had, because you can go, hey Google, or okay Siri, or I don't use okay, I guess hey Siri and okay Google, right? I don't use those interfaces myself, but ubiquitously you can ask questions and gain access to information, right? And somehow, despite all of their sophistication, all of our supposed investment in research and development, the interfaces that we've created are not as advanced as the general problems that the likes of Google and Apple and others have already solved for consumers. So I think like for knowledge graphs, they're going to become more and more prevalent in the enterprise, and they're going to drive a lot of the interfaces that people have today. Chat, voice, all of these are underpinned by knowledge graph, and we're going to see that expand greatly. So how people engage with data, with analytics, with insights, with information systems is going to be vastly transformed. It may not be visible to the business users, but it will be enabled by them. I think that's an incredible trend that I feel has already started, but it's just going to accelerate. It's going to really start the second peak, right, of returns and value. The second trend that I'm very keenly looking to is that our operating models are going to be underpinned by these graphs, right? So graphs are going to become far more two things really. They're going to become far more rapidly updating and self-organizing, right? We cannot necessarily be going in and creating nodes and relationships and attributing them at the speed of humans. So what we're going to see is that knowledge graphs from I'm going to just use this term once, as a base of knowledge, right? So knowledge graphs are going to be the primary mechanism for us to capture and maintain knowledge faster and far more broadly than we do today at essentially what I think of as human speeds. It's going to move to machine speeds, and that's going to have profound implications to how different industries operate and how rapidly and well we respond to stuff. An example of this is, right, like, in hindsight is 2020. Monday morning, whatever, Thursday afternoon, quarterbacking is very easily said, but a lot of the impacts of and the trials and tribulations and troubles that we went through the pandemic, I think that a knowledge graph would have connected those dots and allowed, if people were concretely using them to do planning and strategizing, we would have had a better response. I'm not sure of outcomes, but we would have been able to respond better. And I see that in the small and the big that applying.
Yep, I totally agree with you on that last point, especially with the pandemic, right? Thank you so much, Mayank, for having shared your journey. I think I'll call it your personal journey of self-realization with knowledge graphs, because you've covered a span of 10 years with experience at various places. With that, I'm going to stop and I'm going to see if Marilee has any questions from the audience. Marilee?
Hi to both of you. That was such a great conversation. Very, very insightful, and thank you for sharing it with us, Mayank. That was great. For those in the audience, if you'd like to submit a question, you can do so by typing it into the questions tab located at the top of your screen. We've had a couple questions that have come in while you're presenting, so I'll go ahead and get started with those. And this one asks, have you ever tried to use RDF or a triple store to build a knowledge graph? And if you have, what did you think of them?
I have. And so one part of my 10-year journey with knowledge graphs I didn't cover was Bloomberg, right? And we focused a lot on linked data. So Bloomberg, as a data provider, their business is making money and revenue out of data. They wanted to describe their constructs really well. And at that point, we chose RDF and linked data to do so. So as a purist, as a theorist, right, I love RDF. Like it's such an elegant way of describing a class of problems and an elegant solution to those problems. But it can be very rigid and constrained in what you can do with it, right? And it does require a level of skill and dedication to make use. So for us, we tend to be pragmatic. We have budget requirements, we have timeline requirements, And we take advantage of RDF constructs and concepts. We learn from them, we grow from them. But a directed property graph really allows us to move much more rapidly, right? We're not necessarily solving general classes of problems, we're solving our problems. And that's, in my opinion, the right approach, right? I don't want to write an ISO paper. I want to help LPL, or I want to help my department, or I want to help that application. And there, RDF is not always the best fit, because you can get lost down rabbit holes that directed property graphs just make easily available. And it's not I don't think of it as a either or, right? Because I think that they can coexist really well across each other. But for our inferencing, for our needs, the directed property graph gives us a lot more flexibility, a lot more nimbleness, and a lot more certainty of outcome and timelines and budget.
Great, thank you for that answer. And we are running a little tight on time, but I want to get this one last question out there and remind the audience that if your question wasn't answered, someone from Neo4j will reach out to you directly, or you can send an email to webinar@neo4j.com and we'll get you pointed in the right direction. But here's this last question, and it's a big one. So this person is new to knowledge graphs. Well, welcome. They're looking for advice about what you can give them on where to start or what pitfalls to look out for.
Sure. I think, so I'm going to take the question in two parts, right? I'm going to assume that they're also new to graphs and they're new to knowledge graphs, right? So the advice I would give is really first learn like graph constructs, right? There's courses all over the place. Where I learned about graph concepts was in my sophomore year in college. So there's all sorts of graph algorithms, but learning about graphs as a data structure and the classes of problems that they enable, and learning about graphs as a data structure within the construct of other data structures is a very powerful way of sort of grokking and absorbing like what benefit and power they can bring, right? From a knowledge graph and a knowledge management perspective, I would offer up a couple of things. We recently, one of my best analysts, right? I think the best analyst I've ever worked with, I'd been pushing her to engage with graphs. We got into a business need to start to define an ontology. And instead of trying to do it on paper or using Protege or like just general ERD style diagrams, we built out that ontology. We built out that concept and construct in graphs. So and she was a convert, right? She essentially took the Neo4j graph trainer course. It was eye-opening from her, from what she says, and so two things were happening. She took advantage of courses and constructs offered to understand graph technology and knowledge graph technology paradigms, as well. Then we applied it to a real world problem without necessarily the pressure of a delivery or a production timeline, but applying it to a problem is really what unlocked. At least for me, it unlocked it. Is what unlocks it. I've seen for others as well. That would be my suggestion: is get into graphs, understand them, and then apply.
Great, thank you for that answer, and thank you again for your insights that you shared with us today. Super valuable stuff. For those in our audience, our next session will be starting shortly, so stay tuned for that. And Maya and Mayank, thank you again.
Thank you.
Thank you.